Good morning, everyone. I realized the volume on the first recording was not so good. I was using the microphone here, so when I walk away, it does it. So I got some Bluetooth things on now, so the sound should be good. I got this working, and we'll be up and running now. If you need, if it turned out it just wasn't good enough and you missed it, I can remake that video uh, in a better version. So just let me know. So you let me know what you need. I'll get it made for you. Okay. Um, Same type of thing that we can do on the homework sometimes. If you're stuck on something and you want like a solution video, I'd be happy to do it. So you can send it to me and we can go back and forth and you'll help me to get better at explaining things in a way that makes sense and so forth. So but today, we got two sections to do, but they're kind of combined. And I cut out more than half of the PowerPoints. So the full PowerPoints are there from the textbook that explain, basically it's like reading a textbook. So let me come here. So these two PowerPoints together are the two sections. They have a lot of sort of foundational information in there. They might be helpful. I cut a lot of it out just to kind of get to the chase. So that's my adjusted one. We'll go with that. And we'll just dive into this. Uh, the way I'm going to teach this section is very heavily reliant on a graphing calculator. So you're going to see me solving all of these with a graphing calculator. Uh, if you do not have, and I'll use the TI-84, but I'll also show the NumWorks. So if you don't have a calculator, a graphing calculator, download the NumWorks on your phone. And I also left my phone at home, so I can't show you that one, but I can do it on the computer. NumWorks is actually going to be much easier because you can just enter the stuff in there. So I'll show you that one real quick. But the goal is, what we're doing today is being able to graph a line. Well, let me draw it while I'm at it. So we got these things, but let's see. I got too excited. I got to get my drawing tools up and running. Here we go. So what we're going to do today is we're going to graph a line. We'll have an equation. And then what we're working with is inequalities. So the line has an inequality. What does that mean? Well, the line is where it's equal, right? The equation's equal. And then the inequality, it's either the top side or the bottom side. It's either one side or the other. So what we end up doing is, say this was the correct area, we might shade that. Actually, the textbook's going to do it backwards, but we'll talk about all that. But that's all we have to do is graph a line and then shade one side of it. Okay, that's all we got to do. Got to do it for multiple lines, and it's going to give us a region, and that's going to give us our answers. The other thing we need to be able to do is use the graphing calculator. And am I yelling? It sounds like I'm yelling. Okay, in here it sounds like I'm yelling, but good. I don't want to yell at anyone. Uh, but so once we got that region, what we're going to find is you'll have a couple points where the lines are intersecting. That's where our answers are going to be. So all we got to do is use the intersect tool. It'll give us everything. So in a way, we're not doing a lot of handwork. We're just graphing, getting the points, maybe plugging in a few things. But if you can do that, you will just really excel at this. And then also we'll look at the homework. It's very visual. So once you've got the right graph, you just pick the right graph out of the lineup. You're good to go. Okay. So this is just basics. You know, what is an inequality? So sometimes this is the issue, is it's a sign. I think of it as a funnel. Some people call it an alligator, but a funnel, what are you doing is you're pouring something from a big thing trying to get into a small thing. So where it points towards the small stuff and it opens up towards the large stuff. Okay, so that's what that symbol is supposed to mean. So this one means that A is smaller than B. This one means that A is the bigger side. Okay, so opens towards the large, points towards the small. If you can get that down, that's good. Again, I'm dyslexic, so I mess those things up sometimes myself. Then there's what they call non-strict inequalities, which means they could also be equal. So we get that sort of equal side. So that means the line is going to be included. The ones we're going to use today are down here, pretty much. Everything we're going to do, the lines that are the boundaries, they're going to be, so it's going to be less than or equal to or greater than or equal to. But we won't do a lot of handwork with it. So just kind of as a quick review, we have an inequality in one variable. What we do is we solve for that variable. So I've got 2x plus 8 equals 89. Subtract 8 from both sides. That's going to give us 2x greater than or equal to 81. And then we can divide both sides by 2. So we get x is greater than or equal to 40.5. If we were to graph this, we'd have a number, just a number line. We'd call that 40.5, negative infinity that way, infinity this way. And since x is bigger than, x is to the right of this number. So, and it's also included, so we put a solid dot and we would shade it. Any number over there will satisfy this, right? Okay, so we're not going to do that. We're going to do it in two variables, but that's a one variable version of it. Okay. When we have an inequality, though, what if this had been negative 2x is greater than or equal to 81? This is the one thing we have to watch for. Yes, sir. You're going to flip the sign whenever you divide by a negative or multiply. That's all you got to remember, right? And the reason is because think about it. If you got $1 million and you multiply it by -1, you now owe $1 million. It switches a negative multiplying or dividing by a negative, switches the magnitude from positive to negative or negative to positive. Okay, so that's why it's going to flip that sign. And so you just have to remember when, okay, I'm dividing by a negative, so this is now going to be x less than or equal to negative 40.5. You can do that, we're all good. Okay, and again, what we're going to do is we're going to do it with lines. We're going to graph these things and then take care of it. But notice, yes, sir. What's that? Because we've got a -2 here. So to get x by itself, we've got to, so this is a different problem. I just said if, okay, yeah, so that's this those ifs that I jumped somewhere, go, where did that negative come from, right? I made it up. Okay, good. So if we had that, okay.
So if it's a negative number, we divide by it, or we multiply
by a negative.
By a negative.
So just watch, multiplying or dividing by negatives with an inequality. You can do it to both sides, but it's going to switch. It's going to make big things small and small things big. That's how the way to remember it. I always do an example. If I've got, I know that 2 is less than 3, but if I either multiply or divide by -1, right? It's just multiply by -1 on both sides. I now have -2 and -3, and that switches the order of those numbers, because -3 is actually smaller than -2. Okay, so I kind of just remember that one because I need that from time to time. We good so far? Yes, sir. Oh, okay. Now let's get into the lesson. What we're going to deal is we're going to deal with these inequalities. I'm not going to do a lot of by hand stuff, but I'm going to show you how we go about doing this to get it into the TI-84 calculator, because that's what most of you have. If we have the numworks, or if you do this with Desmos, you can just actually enter this and it will graph it for you correctly. Okay, so that's the cool part. You just enter this with the inequality and it's going to graph it for you. If we've got a TI, we have to do just a little bit of work, and I'm going to do the minimum amount possible, right? That's, we get paid this much. Unless you pay me more, I'll just do the minimum, right? So what we're going to do is we're going to solve this for y. So I subtract 2x from both sides. Now I don't have to flip the symbol, right? I'm subtracting, not multiplying or dividing. So then I get 3y is less than or equal to 6 minus 2x. And notice I'm just kind of doing it that way. What do I do next to get y by itself? Divide by 3. And the way I'm going to do that is I'm going to put a parentheses here, divide by 3, divide by 3. So I get y is less than or equal to 6 minus 2x divided by 3. Because that's the simplest way I can write this. And now I'm ready to put this into my graphing calculator and get the answer. Okay. I notice that y is less than this, so what it's going to do is I'm going to show you on the TI calculator, it has a shading. It'll either shade below the line or above the line. When we have less than, are we below or above the line? Is y less than or greater than this side? It's less than, which means below. Okay, so your intuition's there. You're probably going, oh, this must be trick. No, y is smaller than, so we're going to shade below. Okay, so watch. We're going to do this. Uh, hopefully my graphing calculator comes up for me. We're going to keep this so far. We are recording. Yes, okay. Basically, once we're able to do this, we just do this multiple times, find the intersection. This is the lesson, and you're going to see, oh, what do I want? I want my calculator here. Take a moment. Once it loads up, we got 6 minus 2x divided by 3. Come on. Here it comes. Oh, has anyone else been sick lately? I'm just finally getting over this cold stuff. Had it. I went to Thailand the first week there. I had a cold. Come back. First week I had a cold. I don't know. Okay. So what we do, y1, we're going to put this in, and I'll enter it just as is. 6 minus 2x. Oops, sorry. Let me come over here. Okay, I'm going to do a parentheses. 6 minus 2x parentheses divided by 3. And what you're going to be able to do is once you do this a few times, you may be able to just look at that equation and sort of, oh, I've moved this over, divide by that. You might not have to write things out. You could just sort of do this. I'm going to go to a zoom standard just so my window's kind of a negative 10 to 10, negative 10 to 10. There's my line. Do I want to shade above it or below it? Below it because it's y is less than. So the y values are below the line. And I did this multiple times to check. You could also put in the 0.00, and you would see that if you put in 00, the equality works, which means it's this side. Because with this inequality, it's either one side or the other. So it's like this is a fence. You either own this side or that side. So how do we do that? Well, we go back to the y equals. We arrow over to this line, the color in the line area. And if you don't have color, you'll at least got the lines. And what you do is you hit enter. You get this little menu. I'm going to keep it blue, but on the line, watch, I'm going to start hitting enter. Oops, no. What do I do? Oh, I hit the left or right arrow. There's a thick line. There's shading above. There's shading below. Okay, I'm going to hit enter. And then enter for OK. When I go back to the graph now, it shades below. So this is what we're looking for. Okay, this is saying this is the solution set. You can do that. We're going to be able to get our answers real for at least the first 4 or 5 of them. That's all you got to do. Okay. Yes. Sure. So you go to y equals, do a left arrow till you get to where the line is. You hit enter. You might just have to, again, depending upon your calculator, if you've got a TI, it may just be when you get there, you hit the left and right arrow. I think that's what you do. Yeah, so if you don't have the color version like this, you just hit the left or right arrow until you see that it's going to shade below. Does that make sense? And again, in a moment, we're going to change that because the book does everything backwards. But it actually, after I started doing it their way, it makes a little bit better sense. Okay, so we get the graph. There we go. So far, so good. Any questions? Because this is important. If we can do this, we can do all of this. Yes, sir. Oh, that is 2x. So you have to go up here to the variable key. Yeah, 2x. All right. So let's go back to the lesson. And I'll show you, oops, oh, I gotta minimize this. We'll be back to this and we'll be doing this multiple times. Wow. Um, Here we are. Slideshow. Here we are. So there's our line. There's our shading. Okay. So this is the solution set. We shaded below. And then all we're going to do is we're going to be given a problem that has more than one line. We're going to do it, and we're going to see what's left over. Okay. And what this means is what this is this is what's called a feasible region. If this was some an operating rule for our factory, this is what our factory can do. This is what our factory can't do. Okay, maybe it's X and Y or how many hours we have to work or something, whatever those are. This is what can happen. This can't happen. Okay, because of that inequality. And we're going to get a bunch of different constraints of what can't happen, and we're looking for get a little region, hopefully, of what can happen. So because we're going to add more of these, can you see how if we put this as our solution set and we have another one, what we would be looking for is overlapping shading. And if we have a lot of them, it might be very confusing what is actually overlapping. So the book in its wisdom, I've never seen it done this way, but after I started doing it, I go, why didn't everybody do it this way? What the book is going to do is they're going to shade what we don't want, and they're going to leave what we do want unshaded. That is brilliant. I've been doing math for like 40 years. This would have saved me a lot of, you know, shading and then trying to figure out what is been shaded 5 times, right? This is, and again, when I first did, I said, they're doing it wrong. But sometimes doing it wrong is better than doing it right, or doing it the way everyone else. So we're going to shade the part we do not want. Okay, so if we had a less than y, what we're going to do is we're going to shade the part above. So it's kind of like, and actually I like working backwards because that's how my brain thinks. I usually do things backwards. Okay, when I was writing, my e's were always backwards, my s's were backwards. I don't know if any of you all were like that. I worked in Kazakhstan for a year, and the Russian e is backwards. I go, I feel at home. So uh, anyway, so we're all good. That's all we're going to do is we're taking what we did, but we're going to switch it. Exactly. That's why I said I was kind of fighting it. I says, but if I don't teach it the way they want it, you go to the homework and then it's all going to be back. So this is exactly how it is in the homework too. So yeah, in fact, we'll even do a few of the homeworks together. Okay, so what they just said is the solution set is unshaded. The non part is what's going to get shaded. So if we just follow that sort of rule, we'll shade the part we don't want. We'll leave the part we do want unshaded. It's going to make our solutions much nicer. Okay, so we're going to sketch a straight line, but we're not going to sketch it. We're going to have our calculators do it. Okay, and again, if you don't have a graphing calculator, you can use Desmos. You can download the numworks. But all we got to do is put in the lines, shade the top or the bottom, and again, we're going to shade the part we don't want, right? So you help me with this, and then we're going to get a little picture. And the first few of the homework, that's all you got to do is you got to just pick out the right picture. Okay. Second part of the homework, we're actually going to find some solutions, and from that picture, we'll see there's where the lines are crossing. Those points are going to be what our answers are. Boom, we're done. Okay, and I'll move ahead. Okay, yeah, we're kind of going to do things a little bit. So we're just going to do an example. Here's 3 steps used to graph this inequality. So we'll take another look. Remember, and I'll do this maybe sort of a shorthand. To graph this, we want y equals. So I always start with a parentheses and 5, right? Because that's what's over here. Maybe I could just do it this way. I need to bring this x over. It's positive on that side, so how am I going to get it to the other side? It's going to become negative x. And then I'm going to have to divide by 2. So see how I could kind of mentally just sort of enter this into my calculator as I'm going? You'll get to, and it was a student who taught me that. So that's why I share that with you. It wasn't me that came up with it. The best ideas I've ever had were not mine. I took them from somebody else. That was back at Oregon State 20 years ago. Um, but it's so much easier. You just take a look at it. Y equals 5 minus x divided by 2. That's what we're going to put in. And that's what we would get. Okay. So that's sort of how they're going to think about it. But we're going to have an inequality, right? We're going to have an inequality. But if we can graph a line, we're going to be good. So you could, I mean, there's multiple ways. In fact, if you remember from your algebra class, you probably spent 2 weeks graphing lines, all these different techniques. We're going to use the technology. That's what business is about. Using your computers, your technology to make things easier. Okay, so we're going to move forward with that. Okay. So if we have an inequality, one way or the other, what they do is they do a test point. Okay, so what I would have done is remembering this, so they test the point 0, 0. What we would have had is y is greater than or equal to, because we moved everything over, right? 5 minus x divided by 2. So since y is greater than, which way is the solution set? Above is the solution set. So we shade below. So we'll just write here solution. And so we would shade down here. What they did is they did a test point and they said that if they plug in 0, 0, it's not correct. So this is not the solution set. That's how they're finding it. What we can do is, because we solved for y, we can just look, y is either above or below the line. In this case, it's above the line. So what we're going to do is use our tool to shade this way. This is not the solution, right? We're going to shade the not part of the solution. Okay, so we can do that directly without having to do a test point. Again, this is the way I used to teach it, but I started, because of that student helping me, once you do it, we've got that tool, it's either below or above, and we can tell by that inequality if we solve it for y, okay, which we have to, right, to put it in. Okay, that's exactly what we got. Shade the bottom part because that's not the solution. Leave the solution set unshaded because it just makes it all easier when we're going to do this. Questions? Okay, let's get into the homework. This is what our homework's going to look like. We've got, well, these are not connected. These are sort of independent, but I want to show you there's a couple in here that we got to take a look at. So this one is something like what we've been doing, right? In fact, actually, what we would do is we would just graph y less than or equal to, we bring the 3 over, right? 3x comes over, that's going to be negative 3x. And then we're going to divide by negative 2. Oops, we divided by negative 2. What does that mean we need to do? Switch that symbol. So that's the key part. Oops, I got to come here. It's no longer less than. It is now greater than. Okay. See how that is? I graph this, and y is above the line, so I'm going to shade below the line. We okay with that? Sort of. 6 minus 3x divided by negative 2. Okay. I'm going to show you this, but I want to kind of walk through the next couple because sometimes we're going to get this. X is less than negative 1. Now we can't solve for y because there's no y there. What does x less than negative 1 mean? What is x equal negative 1? That's a vertical line. You can't graph that with your calculator. So you're going to have to put this in mentally, and we'll do this sort of. So what this is x, so think of x equals negative 1 would be this line. X less than negative 1 means the solution is over here. And so that means we're going to shade this side, right? We're always shading the side that doesn't solve our problem. But these ones, we're going to have to kind of do manually. We're going to have to see it. I'll be able to draw on my screen what we're doing when I use my calculator, but you're going to have to just say, okay, this part is not included. Okay, so there's a few of those in there. What about y is greater than 0? What kind of line is y equals 0? Horizontal, exactly. So it's, whereas y equals 0, that's actually the x-axis. So that's this line. Y is bigger than 0, so that's the top part. So remember, we will shade the bottom part because this is not the solution. This is the solution up here. Okay, that one you can do. You can put y equals 0 into the TI calculator, and then we would shade the bottom because that's what we don't want. We want to leave that one. So that's okay. And then this one's not so bad. We can solve it for y. Again, just divide both sides by 3. You get x over 3 is greater than or equal to y. Your calculator, you're going to put it in as y. This kind of, you're going to have to flip it over. You put the y in first. So the symbol is pointing towards the y, so we leave it that way. So this is what we put in our calculator, x over 3, and y is less than. So the bottom part is our solution. We shade the top part. Okay, and they showed these. So this is the line of 3x minus 2y equals 6. And remember, we want the solution set to be greater than, so we shade the lower part. That's what it would look like on our calculator. Okay. Here's our x less than -1. So this is our solution set that I drew. This is not the solution set. Okay. There's the y equals we want above, so the solution set we leave alone. We shade the non-solution set. And here's this one, y equals 1/3 x is that line. And we had greater than, so we had y, yeah. So actually y, the way we did it, we flipped it over, y was less than x over 3. So our solution set is below the line. We shade above the line. Make sense? I don't know if I did this, but I talked about it. But the line would be something, it's got a slope of 1/3, something like that. Y is less than, so we want the bottom part. This is the solution. This is the part we don't want. Okay, and that's exactly what we got here. So there's these examples in the PowerPoints. And again, if you want to go back to the original textbook one, they got a lot more writing in there. Sometimes that's helpful. Okay. So now what we do is, these have all been called unbounded because the solution just kind of goes either down all the way or up all the way to nothing bounds it. What we're going to see is we're going to get enough of them where they will enclose an area. That's called a bounded solution. Okay, so we can work with both of them, but unbounded means, hey, there's really no limit to what you can get, either going up or down. But if we've got the bounded solutions, that's it's going to be better. So that's basically 6.1. Now I've got about 20 minutes to do 6.2, but we've got all the tools now. All we're going to do is put it all together. Okay, so here's the thing. We're going to have some, so we've got, what is this? This is, okay, so we've got what we call an objective function. We want to make a profit, whatever, and we want to maximize that. Or we've got a cost function, we want to minimize it. So we've got some function we want to either make a minimum or a maximum. We will be given some constraints, which means we only have so many workers, we only have so much material, whatever that is. And we've got some word problems to kind of put all this together, and we'll do one of those. What we'll do is we'll graph the constraints. We'll see what that feasible region is, where the solution could exist. And what we're going to find is that one of the points in those crossing lines is where the maximum or the minimum is going to occur. Okay. So let's do one. Our constraint is that x plus y equals some number, and we want that number to be as big as possible. Well, that's 1 million plus 1 million is 2 million. Is that big enough? Well, that might not fit in the constraints, right? So we've got to graph this and see what's possible, and then out of the possibilities, we're going to be able to find how can we maximize that x plus y function. Okay, so this is the way it is. We're going to be given a series of inequalities. We're going to graph them. And this is where it comes good to be able to say, okay, I want y equals. So I'm going to have 12, because 12 is already there. I'm going to bring the x over, so it's going to be negative x. Then I'm going to divide by positive 2. Y is left over here. I got less than or equal to. So I didn't have to flip the symbol. See how we can kind of do that without having to write down too many steps. Start with what's on the other side. Move the x over, so it's going to change its sign. And then we're going to divide by whatever's in front of the y. If it's negative, we will flip the sign. If it's positive, we're all good. Okay, we're going to graph that next, but let's continue. How about this one? This constraint, I also have a 12. I've got a 2x, so I'm going to bring that over, minus 2x. And then I've got a 1 in front of the y, so I'm going to divide by 1. And it's also less than or equal. Now, you don't have to divide by the 1, right? But I like to put it there because whatever's in front of the y, I divide by. I just consistency. And then finally, we've got x greater than 0. Remember, we can't graph that, but that's going to be x equals 0 is the y-axis, and it's the positive region. So we're kind of going to just have to picture that. This y greater than 0, this we can graph, so we'll go ahead and do that. Y equals 0 is the x-axis, and then it's above there, so we'll graph below it. Okay. Now, I don't think, I might be able to do this all on one screen. Let's see. Keep these. And we're going to get to our calculator. Let's, oh, I don't want that. I want, okay, well, let's see if I can kind of remember from here. So I'm going to clear this out. This is kind of you got to kind of come back here just to reset. I haven't found a quick way to reset these other than to come back and just say, not sure which way I want it to go yet. We'll just put it as a line. Okay. So I want to put the first one in, and that was parentheses 12, oops, parentheses 12. Is that one minus x? Okay, so minus x, parentheses divided by 2. Right, this one was divided by 2. And I guess I can move that. That was y was less than that, right? So the solution set is below this line. I'm going to graph above, I'm going to shade above the line. So then while I'm doing this, I just come over here and I want to make sure that this is going to shade above. So actually I think it was the correct one. You're going to change them anyway. So, and then the next one was parentheses 12 minus 2x divided by 1. And again, you could leave that off and that'd be okay. And y was less than, so we want below the line. We're going to shade above the line. Okay, so I come over here and enter. I'm going to shade above the line. Remember, you're kind of always doing backwards. This is what we don't want. The final one, oops, let's get out of there. I want to come, I got to arrow over, is y equals 0, but we've got y greater than 0, so I want above the line, so I'm going to shade below this line, right? So that's enter, I want to shade below the line. That's what I want. And again, with the colors, you could have the different colors. The nice part is you're going to see the white part that's left is our solution set because we're doing it this way. We're doing it backwards, how most textbooks would ever teach you to do this. I'm going to graph it. There's that shading, there's shading. And then remember, we have to kind of just visually, I don't think that's going to work for me. Uh, we have to visually say that x is greater than 0, so we don't want this part here, okay? Let me go ahead. I should have started this tool. Let's come here. Oops. I got a special tool that helps me with this sort of stuff that just draws on the screen. Where is it? Oh, there it is. Move this over. So we just remember we've got this additional line here of x equals 0. We don't want this side. And again, try doing that on your graphing calculator, right? So this is the little area we want. What we're going to find, so the first few problems, this is all you have to do. You see this picture, you've got 4 or 5 of these to choose from. Choose this one. That's all you got to do once you've got a graph. Second part of the question is what are the possible solutions? What we got to do is we got to find these intersection points here, 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 and here. Those are the possible solutions because they're at the corners of the solution set. We'll prove that to you in a moment, but we'll see that that works. So we go find these, and the way we can do that, my tool back here, is we've got a tool in here. First of all, you could see, I think, this little point down here would be 0, 0, right? So we can see that, let's see, I'll write it. So 0, 0 is a solution, and then 0, whatever that is. So there's a couple tools we can use here. I'm going to go second, trace, which is the calc button. It's a little messy right now because I've drawn on it. What I'm going to do is I'm going to go to number 5, intersect. Now the intersect tool, what you do is you have to get on the 2 lines. So it's going to ask what's your first line, what's your second line, or curve, as it's asking where's the first curve, second curve. You click them, and then it'll find the intersection of those 2 curves. What I want to find is, arrow over here, is this one that I've got circled here is the intersection of these ones. So I'm on the first line, enter. Notice it jumped to the second line. That's the other one. I hit enter, and then ask for a guess. I hit enter again, and it gives me that intersection point. So this is all going to be done visually. The intersection point is 4, 4. We're going to find out that's actually our best answer, but that's a possible solution. So I'll write that down. Now it's a little bit harder. Well, this one down here I could find also, right? The one down on the y-axis. I can go second. Oops. Yeah, we'll second trace, which gives us the calc. I'm going to go to number 5. I'm going to keep going on this. No, that's not the line I want. So I go, the up and down arrow gets you to change lines. Okay, that's the line I want. Yeah, because I'm looking for this bottom intersection. I'm going to hit enter. And then that's the other line I want. I want the y equals 0 line. And I want to see what that intersection point is. And so I hit enter for a guess. And that's the point 6, 0. Okay, so that's another possible solution that would maximize us. 6, 0. Now this one at the top, since I can't graph x equals 0, I really can't do the intersection. So instead, what I'm going to do is I'm going to go to, let's see, actually, I'm just going to go to turn this thing off. I'm going to go to trace. And now what I want to do is, yeah, I'm on the right line here. If I'm not, remember, up and down, I can change which line I'm on. I'm just going to keep walking this thing over until I get close to that point. And what I do is on this line, what do we want x to be? I can see I want x to be 0. What I found is I could just I can just enter the number 0. So I got x equals 0. I hit enter, and it tells me when x is 0 on that line, y is 6. So I couldn't use intersect because I can't draw that other line, but I can see the other solution is 0, 6. So those are the 4 possible solutions, 1, 2, 3, 4. Those are the corner points. One of those is going to maximize the equation. And what was our equation we were working with? X plus y. That's our objective, is to maximize x plus y. Well, just looking at these numbers, which ones do you think is going to work? Well, 0 plus 0 is 0. That's not very big. 0 plus 6 is 6. That's better. 6 plus 0 is still 6. But what's 4 plus 4? 8. Which one bigger? 8. So 4, 4 is our solution. See how that works? So that's all that's all the problems are set up this way. Now, we only got 5 minutes left, so I'm not going to get the time to go through and do one of the word problems. What I'm going to do is during office hours, if no one else comes, if you come, I'll work with you, but I'll finish this video with an example so that when I post it tonight, you will be able to, I'll work through at least an example, and I'll even go into the homework and work one of those. Now in the homework, any red numbers, yours may be different. So be careful. Our problems will be very similar, but your numbers might be a little different. So make sure you use your numbers when you put it in, because if you use my answer, it might not give you a correct answer, but I'll do that. But let me, instead of trying to prove too much, I could sort of do it here, but the video, I think I've got it all stored in here. Come back here. Okay, yeah. So this is what we did. We maximized. This is what we, yes, sir. Because what we're trying to maximize is the equation x plus y. So you take the, yeah, so, and what we're going to see is if that maximized equation is different, then we have a different, we would have done something different. And so they're going to show us here. So this I can just kind of, in 2 minutes, I can walk you through and show you. We did all of them, actually. We plugged all of them in, and then we took the biggest, because 4 plus 4 was 8. That was the biggest answer. So is that always the case? It's always the case, yeah. So this kind of does it in a little bit more organized fashion. We get the feasible region, right? So this, we did this with the graphing. We found these 4 points. A lot of words. We did this. Here's our coordinates for the points. We put them in the maximize equation, and we came up with these answers. 8's the biggest number, so this point is our solution to our problem. What they're showing you now is that if you were to graph x plus y equals various value, if you could put, like, if it was equal to 2, you'd have this line, this line. If it was equal to 6, you would get these two. So it's just showing you that with that you get a series of parallel things, and that's why these vertexes is always where the solution is going to be. Okay, 10 isn't because it's not in the feasible region. It is a more maximum, but it's not feasible. We can't do it. We don't have the resources. All we have the resources to do is 8. So this is the best solution we can get. If we change that maximize the objective function from x plus y to something else, we might get a different solution. So had it been x plus 3y was what we were trying to maximize, then this would have been the solution, because this gives us 18 versus what we would have got over here. Okay, so that's, but notice it's the same feasible region, but it depends upon that equation. So we take that, plug all the values in, and we just look for the one that gives us the biggest value. But it will always occur at one of the intersection points, which is cool. If you just accept it on faith at this point, you'll see it always ends up working. And that's sort of what I did. I go, really? Is that going to work? I don't know. There's not really a good proof for it, but it does. Sometimes it just works enough. So that's what we're going to have you do. I'm going to, let's see. Yeah, this kind of talk. I'm going to do this one. It's a resource allocation because there's homework problems like this. So this is, as you get down, you're ready to do at least the first 4 or 5, 6 or 7 are not too bad. But then they start giving you word problems. I'm going to show you how to set these up. I'll record this one, and then I'll go do maybe a few of the homework problems. And I'll add this so when I post this by this afternoon, you can take a look at these and keep moving, because we're just going to have to do it this way so that we can keep on track. And then remember, we've got some scheduled open time. Those in-class quizzes, I'll make them short, but those will also be times where you can ask questions and we can go back. And remember, there are no sort of due dates for any of the homework except for the day of the tests. But try to keep on track. I did take a look. Many of you have actually already finished that first one we did. Some of you haven't started or hadn't started when I looked last night. That's okay. Nothing's late. But, again, we want to keep you on track. Don't wait till the day before the test to start the homework. It's a lot, but just, keep yourself going, make your schedules, but make that time. Okay. Sometimes I'm one who does better when I don't have stress. You put all this time stress on me. It takes me twice as long to get things done when I got that. Take the stress off, have my coffee, do my whatever I'm going to do. I get it done better. And so that's what I'm working with you. Well, we're out of class and there's another class that comes in here. So I will record it, but you'll have to watch it maybe, and I'll try to get it up there by this afternoon. Okay. Thank you all. I'm getting on track here. So sure.